Conferencia a cargo de Rafael Sachs, profesor asociado en Israel Institute of Technology. Cuenta con años de experiencia en diseño estructural y desarrollo de software para la industria de la construcción.
Well, good morning, everybody. Buenos dias. Thank you very much for the invitation. It's a real pleasure to be here and to take part. I know many of you from the research in the different fields of lean construction and building information modeling, many for many years, and so it's really a privilege to be invited to speak before you. And a very special thank you to Maria for organizing my classes this morning. Long story. I thought that I would talk with you this morning a little about building modeling and lean construction and the synergies between them, perhaps as a way of introducing what, at least in my view, are perhaps the most significant changes that we're seeing in the construction industries in the industrialized world and in many places. These are two areas that I've been involved in research for years, and it's very gratifying to see them come to fruition in many ways in so many countries and with so many industrial companies getting involved. So a quick abstract of what I'm going to speak about. I hope, I assume that the slides will be available to everyone afterwards, and so you're welcome to have a look. But I thought I would begin with this. This is a little story from Pooh Bear, which at least in most English-speaking countries is a very, very well-known children's book, and the very first book in the series begins with this piece. And you can read it here. What it's telling us a little bit about is how difficult it is to make changes, and that sometimes we know how life runs, we know how life on a construction work runs, and we know how it works, and it's within our comfort zone, even though that comfort zone may be very uncomfortable. Here's another language. But the message is that unless we're able to step back and take a look at what's actually going on, then it's very difficult to change. And I think that the role of academia and of researchers, apart from finding out new things, working out new ways of doing things, especially in engineering research, part of our role is to be a mirror, to be those who are able to step back, look at what's being done, and figure out what's being done that could be improved. Because we're not buried in the day-to-day details of what we're actually doing, of construction management. And so I thought that I would try to do that a little bit and look also at some of the theories behind BIM and lean so that we can use that perspective to look back at the construction industry and say, well, here are some ways of thinking about what you're doing that could be different. And of course, I haven't started this. There are many who've come before me, both in the area of BIM and lean, but I think that there's still where to go in terms of developing the philosophy and the theory. So let's dive in and have a look. So I'm going to start with a little bit of background about the theory of production in construction. And I know that for many of you who have researched in lean and in waste, some of this you know. But nevertheless, I think it's worth looking at the thread of the thinking. So we know that lean is all about waste, but it's also about transformation, flowing value, and I'd like to show you a perspective that we've developed more recently that we call the portfolio, process, and operations model. Well, that's a rhetorical question. That's why it doesn't have a question mark, but an exclamation mark. Yeah, we can all see the waste, and the first thing that most people think about when they think about construction waste is exactly that, the physical waste. But then you can look at a photograph like this. This is a residential project at home in Israel, and it's very difficult to see the waste unless you train yourself to see it, and then you have a look and you say, well, on all these floors that are complete, what's going on? Or here? There's nothing being done there. So that represents a waste of opportunity in the sense that we have products here, we have the apartments, the locations, but nothing's been done with them. We've invested money, we've created them, we're paying interest perhaps on having that waste there, and yet it's not being exploited. And that, from a lean perspective at least, that represents a significant waste. And we can translate that into extended durations, construction durations, of course, because that will take longer. And then you look at a photograph like this, and construction people look at this and say, wow, that's a very clean site and a very clean partition wall at the entrance to an apartment where there's no waste there, that looks perfect. Then it takes some time to think about looking at these blocks up here, that each and every one of them has been cut on the site. And these blocks over here, they had to be filled in. And these ones here that are cut, and a great deal of other things. So we then need new ways of thinking about this. And one of the most valuable ways of thinking about this that we've been given is the transformation flow value ideas that Professor Lauri Koskela has contributed. There are really three ways of looking at back production. The first one is this transformation view. So we know that we have inputs and process and outputs. And then we take that process, that sort of black box, and we break it down. And we build a work breakdown structure that's all very traditional. And we have process A and process B. And this is very powerful because it allows us to decompose, and it allows us to reduce our level of detail. And so we can also plan. It also means that we can look at these things as being independent of each other. So that gives us, from these ideas, the concept of productivity and the concept of a task. And it allows us to then invent the critical path network, which has all been done, of course. And that has been the cornerstone of a great deal of construction management for a long time. But then we come along and say, well, what about another way of looking at it, this flow view? And from Professor Koskela's PhD thesis, which came after a research report many years earlier, we see this view, where we say, well, in the previous model, we only had process A and process B, but actually, if we lay this out more thoroughly and think about it more deeply, then we have some moving and some waiting, and then some inspection, and maybe some scrap, and maybe some rework over here, and only then we have some more waiting in between and moving before to process B. So the message of this is that there is a lot going on outside of these little black boxes of activities. And if we ignore what's going on between all those activities, then clearly we're not going to see the whole picture. And also clearly any measure of productivity that is only concerned with the process itself is missing all of the non-productive time that's going on in all of these other things. So you might say then that the big idea of lean construction is that production happens in a pipeline, so we can think of a flow of work, that there are, in that pipeline, there are good stages and bad stages, the processing and the rework. If we get rid of the bad stages, the in-between stuff, or at least we minimize them, then we automatically improve productivity, we reduce cycle times, we reduce work in progress, and there are specific ways of doing this that include what we call pool flow, the way that we schedule our work, small batch sizes, stabilized production. And we make we reach the understanding that processes are not independent, they are interdependent. They do depend on one another. And you cannot measure the productivity of a single activity without thinking of the productivity in another activity because they impact one another. They're not independent. They may be covariant, but they're certainly dependent. From manufacturing, we bring this little sort of pearl of Little's law that really helps in many, many situations to put your finger on what's wrong with the whole flow of a process. So now when I come back to this image of our partition walls, well now, if you look in between when the wall was being built or after it was being built, then you can start to see some of these wastes. And when you lay it out over a timeline, of course, then you have a lot of the activities are here, but the in-between times are much longer. And so that the overall timeline or cycle for a partition like that could be 4 to 5 months rather than the 2 or 3 days that it actually takes to put block on block. I mean, for those in the lean construction community, this is sort of Lean 101, but when you go and model this in a building information model, and you measure it, and you actually observe it on site, we found on our typical sites that the amount of work of actually laying blocks was about 32%. So if you're measuring and improving only the activity of laying the blocks, then clearly you're only attacking 30% of the problem to begin with. And even there, it's already quite productive. So much more useful to try to look at all this stuff and see how we can improve those or eliminate them. And of course, there's a great deal of it. You can see it there. Now, in order to do that, we can also be inspired or take understanding from manufacturing. And perhaps the most thorough production model of manufacturing is this model of Shingo. Shingo worked in Japan and opposite many of the manufacturing industries there. And the model created had two axes, this processes axis and the operations axis. And as I've tried to show here with an example from the construction industry, although a manufacturing example of windows and doors, these are two different products. So they each have their own process line, if you think of it that way. So we start with some profiles, and then we move them around, and we cut them, and then we assemble them into some sort of frame, and we end up with a window. Okay, great. The same with a door. We can start with some wood, we can move it around, we can cut it, we can wait some more, we can join it together, and we end up in stock. Now, those are what we will call processes. So we have a process that creates a product. But on this axis, what Shingo showed was that there are operations, and those operations are common, in many cases, across different products, and it doesn't matter what they are. So you have things like cutting or joining or weighting or moving or raw material stock or product stock that we can think of as the operations. Now, when we think of this in terms of construction, well, we have to make a flip because, of course, we don't have now products that are moving. These things are moving along the line, whereas the operations, these machines are static, they don't walk around. In construction, of course, we have the opposite, and so you can think of it this way. And in this way, we have locations. So A1, A2, A3 might be a floor in a building or an apartment in a house, or it might be a series of houses in a big housing estate. It doesn't matter what they are, but these are the basic products we're creating. And those products don't move. They're fixed in location. Whereas the trades, they do move. And those trades are similar to in what in manufacturing we would call the operations. So in fact, we have processes here, and we have operations running here. And I show it in this way as an arrow in that direction as part of a line of balance style representation. And that would be for project A. And the other thing we can be aware of is that we have flows. We have different flows flowing into this process. There are feeder flows that are providing the oxygen, if you like, that keeps this going. And then we make some observations about this. So firstly, we can see that if this is a typical project, well, an atypical project, actually. We have the timeline, we have the floors in a building, and then we have the different trades working along. In this ideal situation, this would be heaven or paradise for any construction manager because the production rate is steady, the production rates of all the contractors are exactly the same. We can see, and there's no rework, there's no re-entrant flow, there's no going back, there's no waiting. Everybody hands over an apartment from one to the other exactly. So from the point of view of construction management or flow, we could say this is one, or ideal. But of course, real projects don't behave that way. And in real projects, we have waiting times. Some contractors are slower, some contractors run one into the other. We build up work in progress. We have waiting times like that. We have going back. We have sometimes contractors work in the same space at the same time, which is very unproductive and so on. Here's another example. And these are very typical examples from projects where you see that it's a bit jumbled. So the first thing we can offer is to say, can we measure this? Can we provide a number? And one of our most recent research projects, and it's just about to be published, says we can create a thing called a construction flow index, and we can use our construction flow index to measure how good the flow is on projects. I think about the Empire State Building in the United States, New York, 1930s, built in 400 days, but actually there's no critical path. In fact, the critical path method had not been invented until the 1950s. So they did not know about that. They didn't know how to do that. And instead, they used flow line planning. Now, this is a reconstruction that we did after a study of the project a few years back, maybe 10 years back. But you can see that that's the flow line, and you can see a number of things. There are no direct connections. That means there were buffers. And it was very interesting to go back and see that they placed the buffers in the right places. That is, after those tasks that were most uncertain, or most unstable. Now, that understanding of flow, we understand, I mean, you can reconstruct these things from a lot of the photographs and the data that's available. But really, when you take this flow view and we take Shingo's model that I showed you, we can then say, well, now we know what the operations are. The operations are the flow of trades. That's these colored lines. And the processes are the flow of locations. The flow of locations over here would be any particular floor out of the 80 whatever floors. If you look at the floor going from left to right, you see they do activity, then some other tasks and so on. So you can, the horizontal will give you the process for a particular product. And the angles will give you the locations. But what we need to observe is that, in fact, there's another level, and that's the level of projects. The projects themselves flow. And any company, any big contracting company will have many projects, and actually the flow, the work, those projects themselves have a certain flow. They in themselves are products. If you think of this, if I take project A and any particular subcontractor, trade X, and I say here are 4 locations in the building, and this is the work of trade X in that building. It may be, very likely, that there is another project, project B, and the flow of work of that same trade X, the same subcontractor, is slightly different from floor to floor. But if you add them together, 2 entirely separate projects, they may be for separate companies, then you will probably see something like this, that those same crew, those same workers, actually moved from project A to B to A to B to A to B. Now, that's very common behavior in subcontracting. Subcontractors, and we spend a lot of time researching this, behave in a way to always make sure that the order books are full. They have overbooking. We have a game theory model for how they do this. And I think in the academic world, and practically speaking, construction managers understand this very well. But what it means then is that the work in project A is discontinuous. Project A suffers, project B suffers. And this is what we call a lose-lose, or a suboptimal situation where we're optimizing the part for the trade, but not for the whole. And what I want to suggest is that we need to be much more concerned about how we manage the work across the flow of projects. So that means we have a flow of locations in project A, we have a flow of locations in project B, we have trades X and Y that actually are flowing through A, but they're also flowing from A to B, and so on. And so we want to add another axis to Shingo's model of production that's specifically for construction. Because we divide it into projects, we add the portfolio. And then, instead of a linear, we observe that actually we have a closed cycle. So the closed cycle says we perform operations in locations. So subcontractors work in apartments. The apartments belong to buildings, but actually there is a flow of those trades across projects. And only if we become aware of that whole, then we're able to think about how we manage the projects to flow one from the other in order to provide sequential flow for the trades from project to the other, which can be very productive. We can reach very high productivity for trades because they have continuity of work without the need to jump from project to project. So, if I just stop there, that's what we now call the PPO model, and it's being used in Finland by a very pioneering company with quite interesting results. So, of course, we can talk about waste, but then smooth flow is the flip side of the coin of waste, as you can see. And when we go into the lean construction principles, in work with Professor Cascala, we laid them out as those. I'm not going to stop. I think everyone can read them up, and I'll provide the slides. Now I want to go to the flip side, the BIM. What's the nature of building modeling, and how does it tie into our lean? Well, it goes this way. This is a project we've been studying recently in Singapore called the Maple Tree Project. And that's just a bit of commercial stuff. what we see in BIM is this, really. Traditional work, we design something, we build something, and then we wait for the mistakes. The mistakes are two kinds. There are the mistakes that were actually made in the design and the construction that are then faults, and there are functional failures in that the building doesn't function in exactly the way we expected. And all of those lead commonly to lawsuits. But then we come along and we say, well, what's the big idea of BIM or of VDC in this idea? The idea is to say, well, can we do the design, create a BIM model, make the mistakes in the model, identify them, fix them in the design, do this enough, and then the design is better, then we go to construction. But if we only do this kind of clash checking thing, which most people learn to do very quickly, then we're still left with the functional failures, because buildings still don't, you can have a perfect design in terms of can you build it, but you can build something that's not functional. So then we make the next leap of faith, and we say, well, actually in BIM we need to do something more. We need to simulate. And those simulations lead here, as well as the modeling, we take that extra step of doing all these different simulations. It can be structural analysis, thermal analysis, and so on. And then we try to recreate the functional failures in the model, improve the design, go through the cycle enough times, and then we get construction, hopefully, of much more valuable products. And you can lay out the ways that BIM does this as a list. The reason I'm doing this now for you here, and without spending the time to go into each one, is simply to draw your attention to the fact that you can then try this novel mathematics, which says that actually, if you put 2 and 2 together, you can get more than 4. We did this, we put those two together some time ago, and we then have along the top all those lean principles, and down here all the BIM functionality. And we try to identify from construction projects where there is an interaction. And where there are positive interactions, we list them, we cite them, we write them up, we analyze them. And where there are negative interactions, with actually using BIM perhaps is making the flow worse, we can also identify some of those. They're not very many, but they do exist. That then is sort of a roadmap, you might say, for saying, well, okay, if I'm a construction company, design company, and so on, I can look at this, I can pick up on any of these and compare what leading companies are doing in those areas to what I'm doing, and then say, if I adopt BIM and Lean in parallel, can I actually make all of these improvements? For example, if we consider the Lean principle of reducing variability and getting quality right the first time, reducing product variability, then this action of clash checking and collaborative multidisciplinary review is actually implementing the BIM idea of collaboration in design and construction. Multi-user viewing of merged or separate multidisciplinary models is the function, and that's the interaction that is positive. There are many, many of these. I mean, as we saw before, there are some 56 that we've identified. Other people have taken this further, identifying more interactions and more methods of interaction. So it's a work in progress. And I thought that if I have a little bit of time, I will show you some quick examples. And I put together 8 quick examples, practical examples of how Lean and BIM interact. So let me show you just a few of them. I'm not sure we have time for all. So the first is this idea of the big room that is becoming far more common in projects, certainly in Israel, in the United States, in Europe, I imagine around South America too. But the idea is that you co-locate the designers on projects that are big enough in spaces where you might have a place for the contractors, for the drywall contractor, for each and every one in some conference space. This is from a hospital project in California. This is the same big room where you see how they're set up, but essentially all of the detailed design is done via modeling, collaboratively by everyone sitting together. This is a housing project that's recently been completed in Israel by a company called Tidhar, and it was a fairly revolutionary project at home because the design and licensing took them 7 months, whereas in most projects of this scale previously it had taken about 1.5 years. And the whole difference in this project was made in terms of going through design from nothing to getting construction permits, was that they set up a big room. The developer insisted that all of the disciplines come along and work in the big room, share models every day, go through the models every day and continue working it through, including putting the construction contractor in the big room, providing their direction and guidance for the design as it was being done. And so you see they have this sort of dynamic of debate as they go through. And I'll show you just one quick example of something, the kinds of problems that previously would have led through into construction, and here they were able to pick them up and solve them in the big room using analysis. What you're seeing here is the headroom provided. This is a parking floor for motor cars, and the contours on the floor here, they give you the headroom. So anywhere where you have headroom less than 2 meters 40 is a serious problem, and it will violate the codes. And so they're able quickly to do an analysis on the model and go back and say, well, any of these areas that have less than the required headroom, we must solve in some way and avoid that reaching an issue during construction. So you could think of many different analyses, but they're becoming very creative. I saw another analysis a few days ago of smoke being taken out of a similar garage. And again, you see quite significantly how these analyses can help. So in that example of the big rooms, the lean and BIM synergies are these. We reduce the cycle time for design development very significantly. We reduce the waste of long design iterations because information flows directly from one to the other within the co-located space. We reduce the waste of errors and rework because they're caught during the design. And we increase the value of the building for the end users, of course. We're reducing overall project duration and hopefully reducing uncertainty and risk. Let's see another one. We can think of this, how does building modeling and lean develop from 2D building modeling to virtual design to VDC and engagement with pool? Well, we know that traditionally we more or less do this. We do some design, we produce drawings, we do some detailing, we produce more drawings, some 2D coordination, and then construction. Well, that's the old way of doing things. So when people adopt BIM, usually the first thing is this. They replace, this kind of modeling where you can find all the intersections, find all the problems. So what they're doing here is often they're taking the drawings, they're creating a building model, they're doing 3D coordination, and they're feeding that back into the detailing a few times, and then construction. Well, that's okay, but it misses a huge part of the value. So the next step that people do is to combine to do the modeling directly. So this is Victoria Station in London. London Underground are rebuilding the underground station at Victoria. And what you see here are subway lines, which just look like pipes under the ground. Crossrail, National Rail, another subway line. And these sort of tubes, are actually where people walk through in escalators and platforms. You see the platforms along here and the different tunnels. Here and here you see different buildings. And you see the platform, the new underground station with all of its support. Now the challenge in doing this project was that they have to tunnel through clay that's soaked in water and completely full of pipes and things. So what they did was, this is called jet grouting. And so they used the BIM model of the whole station in order to guide the jet grouting precisely to where they wanted to go. These jet grouts then create sort of piles within the ground that they can then tunnel through safely because it's all concreted. And what's really happening here is that they're, instead of drawing, they're modeling everything. They're doing the models and the modeling and the coordination. But in the end, they're creating the data for construction directly from the model. And in that project, all of the locations of the drills were taken directly from the model. There were no drawings, so to speak. That's really good because it means that we can reliably build the model. And that's what most people would call real virtual design and construction. But we think it should be taken further. And in this project in Singapore, they are using the models, as you see, on the construction site. Every day, all the workers walk past these boards, and they all have access to the models. Now it's becoming far more common for them to have iPads or tablets of other kinds, but even without them, you can get very big impact. You can gather the workers around the boards in the morning and understand what's going on. You can see here in the same project, the maple tree, things like this, where layout of the HVAC systems is already being done with augmented reality, and it really is guiding the work. So, but even there is still another step. And the next step is to say, it's not enough that we build the model. What we also have to do is we have to time the modeling itself using pull signals coming from the construction. And it's a fine point, but it means that we don't model things and we don't do the detailed design until what we call the last responsible moment, and only then we finalize design and feed it directly into construction. And that's the lean part of the BIM in this case. And if we do that, we gain the following: minimal design whip, minimal rework, short cycle times, correct sequencing, and better production flow overall. I think we probably have time for just one or two more quick examples, so I'll show you these. Using BIM to reduce. Probably many of you have seen this 4D. This is a project of Hyundai Motors in Seoul in South Korea. And the intriguing thing about this model is that actually the construction sequence is opposite to what we would expect. And by virtue of the BIM, then we're able to see that the way to begin the steel work here and then here is to work from the top down. So they're building this hanging from the concrete tower and only eventually creating the joint between the two models when they get there, so that they were able to work as two projects and work one toward the other. Similarly, we do this is the same maple tree project, planning the cycle time for a single floor in order to remove the waste. I talked before about the flow of work. They're using the modeling to plan that flow of cycle time to very, very precise detail. The same thing in this project in Israel that I showed you before. Each of the colors here represents a day of formwork. And then what they do in this is they use the modeling in this way. This is all done with industrial-like formwork, so the stone cladding is attached before, and then they hoist them up to the floor. So they model it this way. They then analyze it and test it together with the crews to see which is going to be the correct sequence. Now, what I want to make the point here is that then in production, they have a very fixed session, and I'm going to go back for a moment and show you this, that what they do then is they color code all the forms on the site. Each of these is then painted with a number on the top, and it becomes very trivial for the tower crane operator to pick. If today is blue, then he takes the forms in the sequence, all the blue forms in sequence 1, 2, 3, 4, 5, 6, and they're able to standardize the production very thoroughly. So what that allows us to do is, in terms of lean and BIM synergies again, is create balance, but also we can have continuous learning, and we can have fixed procedures that can measure and then improve. And they did indeed improve cycle times here, and they reduced the crew as well. I'm going to skip this one, with your permission, because we've seen a lot about that. There is a great deal more now of off-site prefabrication, which is thanks to the BIM. But I want to skip to this one and talk a little bit about using BIM for production control, which is really a direct use of the modeling for a lean purpose. And what you see here is a model being used by a team in last planner meetings. So they have last planner meetings on site, and then they're using the model. And a lot of this builds on ideas that we presented some years ago in research called CAN-BIM, where we said we want to have pull flow control, Kanban, together with BIM. And that led to location-based planning, modeling being brought together in these kind of interfaces where we're able to show the model, but these labels, they tell us about the activities that are being done. They give us the maturity of the work here in these color codes. They tell us who's doing the work and how important it is in terms of pull. And this is a tool that then enables the whole team to understand the status of work on site and to schedule their work accordingly. There are, and you'll get the slides, so there are a number of YouTube movies about this. You can look at CAN-BIM and find them, and that will give you a much better understanding of what the principles are. We also did a lot of research to test these in simulations, and this is one from an agent-based simulation where the idea was to say, how do people behave? How do foremen, how do superintendents, how do workers behave? They make decisions every day on the construction site about what to do next and where to go that are not necessarily the way that the manager thought that that's how the project will be. And if we could model those, we could figure those out. And that's what we did. And we're able to show that using the CAN-BIM, we were able to get quite significant improvements in productivity, in schedule, in WIP, and so on. The idea here, in terms of lean and BIM, is to use the modeling and the lean principles of flow to empower workers, to create a place where a lot of the decisions are emergent and not necessarily tightly command and control from above. And I'm going to skip that one because it's much less interesting, I apologize. The final example is this one of client change coordination, because we find that changes in design really have a very big impact on the flow of work. And so what we really want to do is we want to have a situation where the client tells the builder what to do, please put the pipe here, and they put it there, and it's finished, with very little change. But in fact, our systems are much more complex than that. And so we have systems where we have a client, and they have a change representative, and a site manager, and a project manager. All these belong to the general contractor. And then we have a supplier, and we have a designer, and all those changes need to be checked by them. And eventually it goes to a subcontractor who gives it to a crew leader. So the client and the builder have become really very separated one from the other by all of this processing between. And it's not to say that we can do without that. There are lots of checks and balances there on quality, on schedule, and so on. So we don't want to do without it, but what we want to do is we want to give the client access to the model. And in that way, the client can begin to see exactly what's going to be done and how it will be done and where things will be. And the model then becomes a channel, a direct channel of communication from the client to the builder, because the builder is going to build what the client approved and understood. Oh, and so, you'll forgive me, I'm going to just skip to the conclusion. And so, in an attempt to conclude vaguely on time, really, Lean and BIM both change the way that we think about construction. We need to be thinking about it as a production process with flow, as a production process with virtual prototyping of simulations and so on, and as an information-intensive production process with two types of information, not just the product, but information about the process, because if we understand the information about the process, and if it's available and everyone can see it, we can much more closely coordinate the process. So what it requires is leadership, long-term investment in people, and technology and processes. And of course, it requires the ability to step back and look just in the way that Pooh Bear needed, as I showed in the first slide. And where it does work, we have quite a lot of evidence now coming from industry that 2 + 2 does indeed equal more than 4. The green ones are things that we know have been tried. The orange ones are things that we know have yet to be tried and could be done. And there are some new ones, and there are some that we're not so sure about anymore. So there's a lot to be researched for anyone who's interested. And I'm going to thank you for your attention and open for questions. Actually, I can kick off with the first question. Can BIM improve workflow waste in construction process? There is a short answer. There is also a much longer answer. And I'll let you read it. Any questions, any comments perhaps? Okay, in any language.
¿Alguien tiene preguntas? ¿Está el micrófono disponible?
preciso de duas traduções. Rafael, congratulations. It's very great for conference, your conference. Minha pergunta é sobre do Big Room. Se as empresas que estão a desenvolver o projeto não se encontram na mesma cidade, como você faz? Existe Big Room virtual?
Yes, okay. Yes, there is a virtual big room, and there are companies who are trying to develop the technologies further. There is a new startup company in Israel, in fact, who are trying to use virtual reality, augmented reality, in order to create a situation where people actually can collaborate very closely in this kind of big room. But there are actually two steps. Our experience with a company in Finland is that very big projects can afford to have everyone in the same place at the same time. And any big project, any airport, any harbor, any major office tower will have enough design work to justify you having even the small trades, like a lighting consultant, in the big room full time. And then you bring everyone together. As soon as the project gets a bit smaller, then some of those designers do not need full time. They can be there 1 day a week or 2 days a week and so on. And then you start to have a different situation, a different dynamic, a social dynamic. And so what they try and do there, what we've seen in Finland, is that they have what they call intensive big room. So instead of full time, they bring people together 1 day every week. So for 1 day every week, everyone's there and they have missions and goals and they do them, and then for the rest of the week, they work separately. The same company then found that was very difficult to maintain, because once you've done 8 to 10 weeks of the main design, then it becomes less intense. So they put together a thing called the virtual big room, and they use the modeling, they use video conferencing and so on. That's not very effective. They found that it's really not worked very well. So they're waiting for there to be much better communications technologies, and then to try have what they would call a virtual intensive big room. And whether those will work out or not remains to be seen. There is still huge value for us to be face-to-face. And I mean, I could have given the lecture by video conference from Haifa, but of course the experience is quite different when we're together. I want to use the question perhaps to relate to another thing about being in different cities and companies being in different cities, because projects are often in different cities. And so people will say, well, how can you coordinate the subcontractors' trades across projects if they're in different locations that are very far? Actually, we have to take a completely different view. We have to say, can general contractors create enough volume of market in a particular given geographical area that they can then create alliances with subcontractors and have those subcontractors work together, not on a single project, but continuously over a long term, so that they create the stability that the subcontractors can follow one another in a sort of a train from project to project in a much more stable way than we've been able to do. And part of the way to do that is to create these alliances where you have gain sharing and pain sharing and stability and long-term commitments, which go beyond the project. But those do need to be in particular geographical areas. There is still that risk constraint. All right.
E, professor? Raimundo Dória, for Brasil. Parabéns pela excelente apresentação. Eu gostaria de ter informações se o Lean com o BIM já teve alguma aplicação na América do Sul. E a segunda pergunta, se o senhor tem desenvolvido estudos com Lean e com Facility Manager para...
No.
Okay.
Translator is not. Yeah.
To translate, because that's in Portuguese. Well, first, I congratulate you for the presentation. And the third question is whether you know about a good implementation case of Lean and BIM in South America. What's your impression about that?
That's an interesting question. I'm not aware, I don't firsthand have an example that I can put my finger on, but I think that this is perhaps a question that we should turn to our South American colleagues. Perhaps Formosa, Luis Fernandez, are you aware of projects, I'm sure you are, projects where Lean and BIM have been integrated in very productive ways?
My answer will be in the afternoon, if you can wait.
So, go ahead.
Yeah. Segunda pergunta, qual? Quer saber na América Latina se... Yeah, his other question is about the integration, the use of BIM for facilities management in public projects. If you know about any cases, advanced implementation on that topic.
I'll come back to the question about facility maintenance, but I want to go back and take a second chance to answer your first question. I'm aware of any projects in South America that have used BIM and Lean very closely together. And I'm reminded, it took me a bit of time to recall, I was extremely impressed in visiting two projects in Sao Paulo 3 or 4 or 5 years ago to see that they were using modeling, not necessarily using Revit at the time, but they were using AutoCAD, but they were creating very detailed models of partition walls, and they were using those details of those partitions to detail exactly every component in the wall, in the partition, and then they were manufacturing the pieces off-site, well, actually in the basement of the building, and they had a very careful Kanban flow system working to bring the bricks, each brick in its right place and package up to the floor where the people were installing them. Now, they were not using Revit, but it was necessary, but it was BIM, it's building information modeling in its purest sense. And it was certainly lean construction in the sense that they had the flow of materials and the flow of workers very carefully worked out with very little work in progress. And as I'm reminded of that, I've seen that in other places as well, and that was perhaps in those projects of Cirela and other companies in Sao Paulo, perhaps one of the most pure combinations of Lean and BIM that we saw at the time. Concerning facility maintenance, it's an area that's growing very fast, but it's an area that's very dependent on the technology. And so we have new examples now of software companies like Ecodomus and others who are specializing in facility maintenance using BIM, and who are finding still that they have to invest a great deal of time and effort to take models from the construction phase and adapt them for the facility maintenance phase. We have case studies we have a new edition of the BIM Handbook coming out next year, and we already have the case studies of the hospital in Stanford in the US, of an airport in Medina in Saudi Arabia, which are doing amazing things of managing the airport using BIM. But there is still a gap, and it's still very expensive to get the models ready. And so there is a new theme called semantic enrichment of building models that is trying to see how we can use artificial intelligence, machine learning and other things to take the information from a model and interpret it correctly to use for all sorts of uses, but specifically also for facility maintenance. I think that will become much more in the future. There's some more questions.
Bien, buenos días, Rafael. Felicitaciones por tu contundente y súper actualizada presentación de Sinergia Lean y BIM, ¿no? Y quisiera hacer un par de preguntas. La primera es, en los últimos años la literatura ha aparecido diferencias entre la línea de balance y línea de flujo. Claramente tu presentación ha usado líneas de flujo Y quisiera que nos explique si estás de acuerdo con esa diferencia entre línea de balance y línea de flujo. Y lo otro es si para examinar la sinergia entre Lean y BIM, siempre se tiene que hacer línea de flujo o también se puede usar el takt time.
Yeah, okay. So, I mean, the real differences between the flow line and the takt time, or the line of balance, are how you use buffers. So in the one you would use capacity buffers, and the other ones you would use location buffers. I don't think it really matters very much. I think you have to think very carefully about the production system and the product that you're working with before you decide which of those you're going to use. And I think in some projects a judicious use of both is good. If you have a very stable product, and every product is very much the same in terms of the quantity of work, then it's very useful to use a flow line where you keep the amount of resources the same. The company in Finland I mentioned before, they're doing piping renovations in apartment buildings, and they are stringing projects one after the other in such a way that they stop relating to the project as the product, but they relate to a bathroom as a product. Now, instead of having a project with 80 bathrooms, you say, no, I'm not interested in that. You say, I have 1,000 bathrooms a year across different projects. And now you schedule on the basis of the bathroom, and you move the crews from bathroom to bathroom to bathroom. Of course, you try to avoid them jumping from site to site, but you try to create an even flow for the crews with stable size of crew. In other projects where you can't do that, where you can't close that cycle of project with crew, then of course you have to think about location-based planning. That could be a takt time planning, but then if the takt time is fixed and the amount of work in each area is not, then you do have to be able to provide extra workers or take workers off at different times. And that's very destabilizing. I mean, I think wherever possible, the preference from a lean point of view should be to have stable crews, because if you can have stable crews and you can have stable groups of crews that work together from project to project to project, you can get learning. You can have learning, and you can have continuous improvement, and you can have respect for people. That creates a social dynamic in the construction site that so far we lack. We've had research projects on individual projects where we've followed the social networks, and when crews don't talk to each other and they meet each other for one project and never meet each other again, you really have no learning and you have no development of procedures. As soon as you have a social network that is stable and is continuous over time, you can get a lot of the benefits of respect for people and continuous improvement that you cannot otherwise. I guess that was a long answer to a short question, so I apologize. But fundamentally, there's no difference really between using the takt time or the line of balance, as long as you are aware of the implications when you set up that production system.
Congratulations for your clear presentation. You showed a relation matrix between principles of Lean and BIM functionalities. Can you explain with more detail what means each number in put in this matrix, please?
Sure. Oh, great. The numbers here are simply serial numbers. So what we did was we said, okay, visualization of form, reduce variability over here. Can we think of particular ways of working that do that, that combine that? And if you, I don't see it here. There is this paper in the Journal of Construction Engineering and Management, by the way, that I could provide if somebody wants. In the paper, it shows the matrix, and then it has a big table that lists number 1, number 2, number 3, number 4, and each of those detail in words what the activity is. So number 36 make me select an approach to production control and collaborate in design and construction. So it might be here that you say, well, we're going to use the model and we're going to put the model on the wall of the construction site and we're going to use that to track and path to measure whether people are there or not and mark them with symbols. So then we would find an example in a construction project of people doing that, show the example, discuss what they've done, and that's what you would find in line number 36. So the paper has all the details, is the best I can answer.
Mr. Sachs, first of all, congratulations for your speech once again. And my question is, we have identified that one of the greatest barriers to BIM implementation in Colombia is the lack of standards. We don't have the same language, BIM language and concepts and workflows. So first, would you briefly describe to us the process that you have followed or Israel has followed towards this issue? And second, would you consider that government-led initiatives or private-led initiatives would massify the BIM implementation in an industry with thinking about the Colombian context or South American context?
Okay, sure. I want to first correct perhaps what might be a wrong impression, and that is that the practice of BIM in Israel is, I assume, no better than it is here or in many other countries. In fact, as a country, the industry has started very late, but it's moving very fast to catch up. So if I want to look for examples of how to go about on a national industry level adopting BIM and what are the barriers, the best examples to look for are the examples of the UK, Singapore, Norway, Finland, United States, perhaps some other countries, but those are on the forefront. And I think that you can see a number of different models, and I think there's only one thing that's common to all of them. You know, you see in the United Kingdom, the government took the initiative, they put together a task force, they started creating standards, and they created a mandate for BIM work for public construction. In the United States, quite opposite. The government really did not step in, but private companies created their own codes, different owner organizations created standards and codes, the American Institute of Architects, the Association of General Contractors, and so on. So it came from the private sector. But there is a common thread to both of those, and that is that in both cases, it's construction owners who are really leading the change. There is a saying that he who has the money is the boss, if you like. It rhymes in Hebrew, but in English it really means that unless the owner says, this is going to save me money, you must work this way, then people remain in the situation of Proubaix. They're coming down the stair, they're bumping their head, but as long as there's food on the table at the end of the day, we'll keep bumping our heads because we can't afford to make the investment to make the change. So in any economy, in any industry, as soon as the owners understand the benefits that they will reap in terms of lower construction costs, less waste, better products, and lower maintenance costs through the life cycle of the building, when that happens, and they write into their calls for proposals and contracts, we demand the use of BIM. And not only do we demand it, we're going to tell you how you should do it. Then things begin to change, and they change quickly. Of course, there are situations where, for example, we've seen construction companies, they say, well, we can see where we're going to save money because we're going to build more efficiently, we're going to charge the same amount, but our costs will be less, we can make money quickly using BIM, and that happens too. But in terms of a broader industry initiative, you need the owners to begin the initiative. And that doesn't matter if they're government owners or private owners. In the UK, it's actually the government owners. We interviewed in January in London, Transport for London, the Environment Agency, the Ministry of Justice to build all the prisons and courthouses, the Ministry of Defence, and the Environmental Protection Agency, Highways England, and all these companies which have enormous construction portfolios. And when they say we want to do BIM, they get together, create the codes, they have the ability to do that and the standards, and it moves ahead fast. In Singapore, it's been a similar thing where the Building Construction Authority have said, not only do we manage our own construction, but we're going to, in a very forceful way, change the way the industry works. And there, they provided funding for construction companies, designers, architects to adopt BIM. In fact, for example, I showed you the Maple Tree project. In that project, 1/2 of the salaries of the BIM modelers was paid by the government during the life of the project to stimulate and encourage the uptake of BIM. And that works very well because people learn how to do it, they build up the procedures, and then the next time it's worth their while without the funding. So there are lots of different models. The key is to get the owners understanding, activity, and then take the lead. In any economy, I think.